Yeah, we're good.
Okay. Um, so I'm Rick, and I'm presenting about GitOps at InfluxDB. And Influx is a time series database. So if you are dealing with data that where time is like an important dimension, you're very likely to benefit from a time series database. We have a lot of usage, which is around monitoring infrastructure, all kinds of infrastructure, a lot of IoT use cases. There's some of other uses like people are collecting trading data and financial data. A lot of that, like the timing is really important. And there's like a big long tail of scenarios that people use us for. And so there's a database, and then there's tools on top of the database to provide visibility and alerting and that kind of thing. Sorry. Okay, so I put this slide here just to remind me to tell everyone, like, I'm gonna be talking all about the cloud and our SaaS service, but we also are open source, and you can just download InfluxDB and just use it like locally. You can use it on the edge. We have versions that'll run on a Raspberry Pi. We have versions, that you can run yourself in production for if you don't use the SaaS version. Okay, so let's just talk a bit about what I mean by InfluxDB 2.0 and what it looks like in production for us. So I just say we call it internally Cloud 2, and it's basically a SaaS data platform, right? So it's available as a service. But the thing about data is data has what we call gravity. What that means is, unlike most cloud services, like if you're using a typical cloud service, you don't really care where it runs, right? Like your HR tools or your Git repository. The cloud that it's running on or the region that it's running in doesn't really mean much to you. But if you are storing reams of data, if you have, megabytes of data, but if you have terabytes of data, copying that between clouds or even regions within a cloud, it doesn't only take a long time, it's super expensive. So for that reason, our users need us to be in the cloud that they're using and in the region that they're using. And additionally, we support private instances, so we can stand up an instance just for you. We use one of those internally, right? So we're multi-cloud, we're multi-region. We're publicly facing and we're privately facing. So you can see why for this reason Kubernetes is very attractive to us, because we can use Kubernetes as a cloud abstraction layer. So we can run reasonably the same code in all of those different places, right? And so the real challenge is, at that scale, how do you do continuous deployment? How do you keep everything up to date? So we chose a methodology called GitOps for this. So GitOps is a way of doing DevOps. Now you can go and you can look at the Weaveworks definition of GitOps. Weaveworks is the company that sort of branded that term and their tools that they make for it. But I think about like signifiers that you're doing GitOps, right? This is like, how do you know if you're doing GitOps? And for me, it's these three main things. So first, if your developers get their code in production by simply landing that code in a master branch, right? So they just make a pull request, it gets accepted, and then with no human intervention at all, just do purely automated processes, that code is delivered to production. Like, that's a big part of GitOps, right? It's fully automated. There's no manual steps that anyone takes. So for the developer, you just have to get your code through CI, land it in the master branch, and that's how you get it out there. But there's also not just the developer's code, but the infrastructure, right? And infrastructure, I mean this in two ways: how you're managing the Kubernetes clusters themselves, and also how you are configuring the way your application runs with Kubernetes, right? Like your replica sets and that kind of thing, right? So when you're doing GitOps, you're managing that configuration, that infrastructure configuration, also as code. And it's delivered in the exact same way. So an SRE or a DevOps person makes a change to their configuration code, gets that landed in the master branch, and then the automation deploys that change in configuration everywhere automatically with no further human intervention, right? So when we use kubectl, we use it rarely, but we only use it read-only. We only use it when we're troubleshooting problems in production. We don't do, like, there's nothing that we apply in terms of changing our infrastructure that we don't do by actually just checking in configuration code. And then that configuration code gets automatically applied. Oh shoot, I forgot to start my timer. Okay, and then the last thing is we call it testing in production. And this does not mean just like jamming out crappy code and like having your users encounter it and get impacted by bugs. It typically means that you're using some kind of feature flagging or concept like that, where your developers are able to keep code integrated into the master branch, even if they don't want their users exposed to that code yet, right? So there's like, that makes branches very short-lived, right? So if you are doing these three things, like that's what we call GitOps at InfluxDB. Like that's our practice, what we consider to be GitOps. Okay, so I have some diagrams to explain a bit how we do it, all right? This is a very simplified diagram, but here's what it basically looks like for us. So we have code and configuration, and we have actually two master repositories, right? And if the developer can get through the gauntlet of writing tests and doing code reviews and makes a pull request, that pull request gets accepted, then in a simplified view, the CI system picks that up, and if everything is good, right, the CI system actually completes the check into the master branch. And then we use this tool called Argo, which is a tool from Weaveworks. Argo notices that the master branch has been updated and then does phase one of the deployment, which is to what we call acceptance, right? We're changing the name of this to staging, but these are some clusters that are only there to make sure that the changes don't utterly blow up. Okay, so that it automatically gets pushed there. When that is done, if there's nothing goes into a crash loop or anything like that, if Argo detects that the deployment was successful, it then moves it into the phase of what we call internal production. So remember I mentioned that we have like private instances. We're the biggest users of that. We call it tools internally. Sorry, this is from an internal presentation, so I have some internal lingo in here. So our tools cluster is a production cluster, but only we use it, right? That's actually the first place that code lands. So if we bust something, we suffer through that before our customers do, right? And then assuming that it works there, then Argo will take it, and basically the last phase is all external production, right? And I'll send it to all the different clouds and the different regions. Now, I'm very much overstating the actual scale that we're running at right now. Right now, we have 2 regions in AWS, 1 in GCP. We are just standing up 1 in Azure, but like our plans are to grow those based on like customer demands for public and private instances. Okay, so this circle here is to remind me to talk a little bit about acceptance. Like we're discussing internally whether this phase helps us or harms us. And in fact, if you look at a lot of the DevOps literature, people out there say like, just go straight to production. If you're wasting your time with an environment like this, like you're wasting your time because it'll never be like production. You're never going to show like the same kind of bugs, which in fact we're finding to be true, right? So I think there's a comfort level of landing it there first, but I'm not sure how much actual value that we're getting from there. The next thing is, this is to represent what I call an automated feedback loop. And I'll talk more about this in a bit. But Argo actually has the capability of hooking into metrics and test results before it goes to the next level. We're not doing that yet. I'll talk a little bit about that later. But we just make sure that the deployment works, and then it'll go for the next phase. But there's hooks where you can run some tests, or you can tell it to listen to some metrics, like your Istio metrics, before it goes to the next phase. I'm going to review the chat and see if there's any quick questions to answer here. Yes, I'm happy to share the slides. We do not keep the infrastructure code and the application code in the same repo. Technically, they're in two different repos, but those are both master. That's just an implementation detail, though. Like Argo could be fine either way. Okay. Are the gates between acceptance and production auto or human approved? Totally automated. There's no human intervention anywhere in the system, unless we get alerted, which I have a bunch on that. This is our actual internal chart. So this is actually how messy reality is. Remember I said it like looks like, you know, ponies, unicorns, and rainbows. Like this is, you know, the reality is a lot more complicated. As I said, you know, all models are wrong, just some are useful. Okay, so this was an effort that we went through last fall to go through from a much more manual process where every team did like deployments when they thought that they were ready for their part of the code to be deployed, to everybody using the same deployment methodology and the same methodology being fully automated. So right away, we saw people working a lot less on the release process, right? Because basically we took it away. Like we do have a team called the deployments team that takes care of our CD and everything, and that's 3 or 4 people. But this was just like an immediate, dramatic improvement to the quality of life for everybody. But what we also saw is that our incidents in production became much less severe and much further apart. And there were, I think, 2 main reasons for that. One is having it be automated meant there were no human errors in doing deployments. Before, we would frequently have human errors, you know, when people were manually deploying. Now, no more human errors at all. The other was that since it became easy to release, people would just release when their code is ready. And so we went from teams releasing like once every week or 2 to releasing multiple times a day. Each of those changes were way smaller, so smaller changes do less damage when they go wrong, and they were a lot easier to troubleshoot and fix when something did go wrong. So just like our lives got a lot better in terms of managing production. So now we have all the automation in place. As we want to add new regions and to some degree even more clouds, it's actually like gone down from a like multi-week effort to like a couple days to onboard a new region, because we have it's all code. And then the other thing is we always know that what's in master is either in production or on its way to production. So we never have any confusion about what code is actually running. And if there's a problem in one cluster, but not other clusters, we know it's something specific about that environment, right? If the code's wrong, it breaks all the production environments, and then we know it's about the code. But if, you know, we're getting alerted from just one environment, we know it's something specific about that environment. So that has been like a huge benefit, just like our time to figure out what the problem is. We don't spend like the first half hour making theories. Observed benefit number 2 seems like a huge shift. We'd love to hear about how that changes team expectations, velocity. It changes, so that's like that's hard to answer. It's really, first of all, there was a lot of fear to overcome within the whole company, not just in the engineering team, to get to this. Now, like, definitely people are much more willing now to step up and do something fast for the product team or for a customer or something. You know, so it's definitely sort of changed how sort of twitchy we can be, but in a good way. I would say. Okay, so now, like this is sort of engineering management to engineering management. I'll get into a little bit more technical depth, and I'm happy to get into any technical depth. It's just like if you're an engineering manager, how would I advise you? If you're like, oh, that sounds really good. We want those ponies and unicorns and rainbows also. Like here's my advice to you to get there. So first, you're going to need some things. So if you do not have CI yet, which it might sound silly to this group to say that, but you might be surprised how many organizations don't really have CI yet. But then you really need to set that up. But more to the point, your CI needs to build your deployment artifacts. In our case, that's containers, and then run unit tests on those, right? So if today you have CI on the code, but then your developers manually build VMs or containers or whatever, you need to teach your CI system to build those. Again, you need a way to represent your infrastructure as code. So we use JSONet, which I'll talk a little bit about later. But if you're not doing infrastructure as code yet, that's like a clear requirement. You need a automatic way to deploy those containers. A lot of people roll their own, which I wouldn't say not to do. We just chose Argo CD because we just prefer to work with other open source projects, and we'd rather contribute fixes upstream or features upstream rather than we don't want to end up with our own bespoke Kubernetes tooling to the degree that we can avoid it. You need a fast deployment pipeline. We thought we were fast, but we just in practice we're finding now that we're not fast enough. You need some kind of feature flagging, because if you don't have feature flagging, then developers have to maintain branches and have very convoluted testing processes before they can release their code. And it's always going to be wrong because it's never going to be tested in a production environment. So you need some way of doing feature flagging. And then of course you need production metrics and reliability alerts. I'm probably going to be pretty heavy on that last part because that's what our whole product is about. People collecting time series data from whatever sources that they have. There's some other things that we think are not nice to have that some people might think that you have to have, right? So first of all, I talked about that automated feedback loop. Oh, sorry, I don't know what happened there. So Peter asked, is there a human at the gate? There's not a human at the gate between deployment phases. But right now, the only thing at the gate is does Argo think that the deployment succeeded, right? So the deployment could succeed with really bad bugs, as we have discovered, right? So that said, going from what we had before to doing GitOps without the automated feedback loop was such a dramatic step forward in our ability to maintain quality in production, that I still consider this optional. I would not block on this if you're trying to implement GitOps. It's nice to have a pipeline for high-level operations. There's a tool called Argo Workflow that we're looking at for that. I don't want to say too much about that just because I'm not really clear on what the requirements are that the team's looking for there. But it'd be really nice to have a feature flagging tool or service. Right now we don't. All our teams have to figure out their own feature flagging methodology. We have too many places where people have to do a deployment to say, okay, this org can look at it, this org can't, etc. Interestingly, especially coming from InfluxDB, I'm going to say dashboards are actually nice to have. It's much, much, much more important to have alerts. And I'll talk a little bit about that. I should have a few minutes. Are you going to cut me off if I start running over? Peter?
When it gets past my bedtime, yeah. But
okay.
No,
all right.
Another 10 minutes would be fine, and we'll still have a chance to talk about it.
Okay.
Cool.
So then there's testing or acceptance environments. right? And the reason I put that star there is, again, a lot of practitioners, and I'm actually starting to lean towards their point of view, is that these environments are an anti-pattern, right? Like, you're wasting your time because you'll never make it exactly like production, and you're not going to find the most important issues there. So if you don't have testing and acceptance environments, I would say just go with what you have, just go to production and make sure that you aggressively feature flag, and then add testing or acceptance environments later if you need them. Okay, so now I just wanted to put a little more technical meat on the bone. So I talked a little bit about JSON. And so if you're not familiar, JSON is actually a superset of JSON. And what it allows you to do is define templatized configurations, right? So in this example, we have like, this would look like a service definition of a Kubernetes service. And then this is a layer on top, right, of that. So we're saying here, add deployment and spec to the underlying class. And then that will output YAML, which is a combination of both of these. All right. If you're not familiar with JSON, I find like some developers are just allergic to it. But as a DevOps practitioner, it's super useful. It can produce YAML, it can produce JSON. So whatever tools you're working with, whatever their input formats are, you can target them with JSON. Okay, so now I wanted to talk a bit more depth about metrics. Okay, so there's 4 types of metrics that we collect, right? So there's, the first kind is like the Kubernetes cluster itself. How are the nodes doing? How are the pods doing? All that kind of stuff. And we just run this tool called Telegraph. It's an agent for Influx. Well, it's an agent for anything, but it can forward the Prometheus metrics to your InfluxDB instance. And so then we can like collect all those metrics. But then we also we've installed Istio. Istio is if you haven't heard of Istio, it's a service mesh. We only really use the reporting part of it. It can do a lot of things, but what it does for us is it sits in between service calls and then reports back metrics automatically about like how long the call took, what the response was, right? To was it 200, 204, 400, 404, 5, whatever is the response code, how long it took. And so we just get reams of data from that. But we also find it's necessary for each team to make their own metrics. We call those custom application metrics. We actually use the Prometheus format for that as well, and our scrapers pick that up. But then we have some metrics for the CI and CD, like the whole GitOps system itself. Okay, so those are the 4 types of metrics. And here's just some examples. So this is our error budgets dashboard. We shoot for 5 nines for our services. This is coming out of the Istio data. It's like really easy to collect these metrics. Do you want me to talk briefly about error budgets, Peter? Like, or we can follow up after maybe?
I was just asking, if someone else chimes in, then we'll go there.
Okay. All right. But basically what you're looking at here is for each service, well, some collection of the services, what are their overall success rates, right? And so like I can just look here and see for like these 2 teams, I don't want them writing features right now. I want them working on the stability of their services. Why are there so many errors? And you need to like get down those errors before I'm going to send you off to work on features. These teams that are green, they're good to work on features. So that's how we use those metrics as metrics. This is another way one of the teams uses metrics. It's like very specific to them, right? And so the reason I chose this one is because this is their custom metrics that they make and that they send over. So this is not going to mean anything to anyone else, but it's just like, how's QueryD doing right now? So metrics are useful, but it's really alerts that are the most important thing to build out of those metrics, right? So alerts tell you when there's a problem in production and that you have to pay attention to it, right? So we basically have, alarm fatigue is a good question. Yeah, that we actually currently have the opposite problem. We are not sending enough alerts, and so issues have been festering for sometimes an hour before we clue into that there's a problem. So like we need to actually throw the pendulum the other way, and then we will deal with alarm fatigue. Now, you could say we have been hit by alarm fatigue in the sense that we had been sending a bunch of like alerts to a Slack channel, but then no one paid attention to those, right? After a while, people just stopped paying attention to that channel. And so then even though there was useful data in there, we weren't paying attention to it. So we're actually in the process right now of going back and selecting like, when do people get paged? Because it's like only getting paged that causes people to actually like, stop what they're doing and going and focusing on that. So I hope maybe in a week or two, we'll actually be suffering from alarm fatigue. So, okay. So we think of like 3 kinds of alerts. There's Kubernetes health, application health, and dead man alerts, right? So Kubernetes health, like once for a very esoteric reason, AWS decided that one of our Kubernetes nodes, like the VM that is running on, like needed to be rebooted, right? Fortunately, we got an alert like right away, hey, your cluster is super unhealthy right now. And so we were able to like pay attention to it and make sure there's no service outage, right? But we also get alerts about application health. Hey, storage is behind. Like people are making writes, but it's taking too long. Things like that. And dead man alerts are very, very important. So dead man alerts fire when your alert system is not getting any data, right? So like if Prometheus scraper stopped working and Telegraph stopped sending us data, if our alerting doesn't get any data for like 2 minutes, it'll tell us like there's something seriously wrong because I'm not getting any metrics. So those dead man alerts are super important. So this is just a screenshot of how to make an alert in InfluxDB. Whatever tool you're using probably has their own system. This is a GitOps alert. And this is a dashboard that I look at a lot, but I think I need to stop looking at it. Like, I think there's this anti-pattern called humans staring at screens. And like, I'm just super guilty of it. And I'll look at this and I'll see very transient things that will alarm me. I'll go bother my team. Why am I seeing this purple thing going up so high? And by the time I go and bother them, the situation's resolved itself, right? So I'm actually starting to think, like, this is what you call a vanity dashboard, and that's nice, but I like have to like stop succumbing. Like I have to rely on the alerts, and I have to like stop succumbing to the temptation to actually like try to do something to make my dashboard look better. This kind of dashboard though is actually super useful. So this is a dashboard that we built when we're actually observing that there might be a problem that we got an alert. This dashboard is reactive. Then we can go here and drill down into the Istio data and then get a sense of what's going on. Like, oh, that's interesting. These regular spikes suggest that there's a client doing something at a regular interval, for example. So I'm not saying dashboards are inherently bad, but just like as an engineering manager, like you definitely don't want to be staring at your dashboard and bothering your team about why the dashboards are looking a certain way. Go invest in alerts. Okay, so just to sum up, there are some organizational challenges that we faced. And one is just like the change of mindset from releases to continuous delivery, Like if we're going to kick a lot of people out of their comfort zone, if they're used to like I have an every 2 weeks release process, to release code as soon as it's ready. The other thing is like, well, what if you do have a breaking change, right? What if you're changing a schema or something like that? Then you have to like exercise a lot more care, right? You have to go in phases where you can, that are additive. And that like just instilling that in a team, especially, you know, a team that's used to like releasing a binary every 2 weeks, that can be really hard. I'll answer your question in a sec, Brandon, and I'll try not to do a sales pitch when I answer it. And then the other thing is like overcoming the fear of breaking production. Like, it doesn't matter what you do, you're gonna break production. Like the key is to get good at unbreaking production. Like learning right away that's broken and unbreaking it. And really those practices will get you better also at not unbreaking it, you know, but just like the amount of process that people put in place because of their fear of breaking production, which ultimately does not work and is wasted effort. You really want to focus that effort on getting good at keeping production, getting production back to a healthy state when it's not in a healthy state, instead of wasting all that effort, that futile effort. Okay, so what are we working on? We're working on that automated feedback loop right now. So like, I think what we'll see is the Istio metrics will actually kick in to block at a phase. We're adding what we call testing to production. So what we want to do is like do a deploy, run some smoke tests, and then use the results of those smoke tests to block deployment to the next phase if we need to. We need a lot more metrics around our GitOps processes ourselves. We're going to implement game days, and this is actually practicing breaking production, like really literally breaking production, and then practicing getting it back online. And then finally, we're looking at different services that do feature flagging as a service, because right now, as I said, it's very bespoke for teams, and we want to make something that's easier for developers, but also easier for the rest of the company. Okay. Thank you very much for listening to me. I'm very passionate about this topic. So I'll stay and answer questions all night if people have them.
So let's see how this works. Everyone unmute and applaud. Ready?
Yeah.
Nice.
Thank you.
Okay, I think I missed a question in the chat. I'm looking for the chat window. I don't know where it went.
What was it about?
Chat, I found it. Hold on. Okay, oh, do you find that needing multi-cloud options being more prevalent to your clients? Actually, no, we haven't found any customers who need our service in multiple clouds, but we have found customers like for different reasons need to use the cloud that they're in, right? They can't copy the data over. A lot of times it's like marketplace stuff, like Microsoft, they bought $1 million in credits from Azure, and so they need to buy anything that's available on Azure. Same can happen in AWS, same can happen in Google. So there's all kinds of reasons why we have to be multi-cloud, but we don't have any customers yet who are multi-cloud. Did that answer the question?
Yes, thank you.
Okay. Circle CI, I think, is that tool. Like,
You were talking about feature flags.
Oh, yeah, there's a bunch of different feature flags as a service. Launch Darkly is the most popular one. We're not specifically looking at that. We're looking at another one. I forget what it is. But like I said, right now, so I'm just being, I feel like I'm just sharing like professional. Like right now we're not, like it's all bespoke and like our feature flagging is very painful. And I hope we can smooth that over. Oh, introducing people to JSON. Awesome. Okay. We talked about error budgets. We talked about alarm fatigue. This discussion, succumbing to dashboard. Okay, so Influx dashboards look very similar to Grafana. Is that embedded, or did you make your own dashboard tool? So traditionally, InfluxDB owns something that's called the tick stack, which is telegraph, influx, and chronograph. And then the K is for capacitor. And those are all 4 separate tools which made up that stack, which you had to put together. And chronograph was the UI piece. And we've had this for a very long time. And it does look a bit like Grafana. What we have done in the 2.0 version is we've actually put that in the same binary. So like you don't have to separately deploy chronograph now. So that makes it way easier. But we have a very tight relationship with Grafana. We, I think, are like people using Grafana to query InfluxDB. I think that's one of their biggest use cases. So we're like, InfluxDB as a backend to Grafana is like one of their most important interfaces. Grafana is different than chronograph in the sense that Grafana is multi-data source. So you can use Grafana to look at InfluxDB, but also many other data sources. And so, you know, if that's what you need to do, collate a bunch of different data sources, then Grafana is a good choice for that. Okay. So if you really buy into error budgets, you push teams to build more features if they haven't used up their error budget. Yeah, exactly, right? And so like, that's where we are right now. Like, how do you spend your error budget? You know, like that's the way I'm trying to get the teams to think right now, right? Like, so if you're green, because if you do a deployment, every deploy is going to cause errors just because things are going to be down for a while. And so like, can you actually deploy, or is that going to spend your error budget? You know, but hopefully you can get down far enough your error budget that you can be a little loose, try some fancy things, get some new features out there, and that kind of thing. How are you guys managing secrets or other sensitive data? Is that a question about like, how do we manage that in the platform?
It's more a question about how you're managing it through your CI/CD process, right? So deploying the YAML files and everything else, fairly straightforward. We've kept our secrets manual. So the question was, how are you automating secrets?
So
or we've used proprietary things like Azure DevOps to store secrets in.
So we use an open source tool called Sealed Secrets, which is a Kubernetes operator, which then can give you a token that you can use to encrypt your secret, and then only the Kubernetes operator can decrypt it. So you're totally free to put the encrypted version of that token anywhere. You can publish it on GitHub if you want, because like nobody but your Kubernetes operator can decrypt it. So that's called Sealed Secrets. And so that's what we use for that. I can sort of recommend it. Like the developer who developed that worked for this company called Bitnami, where I used to work, but then like we got bought by VMware and then he went off to AWS. So it's not that well maintained anymore. So like I can kind of recommend it, but someone said split ? Not sure what that is. Okay, so then someone said, how do you like JSONet compared to Helm? Man, I love these questions. Like, I love this stuff. So this is like really fun for me. So JSONet and Helm are actually, that's not an either or situation, right? So like Helm is essentially like a packaging tool that you can use to package your application, right? And so if you want to like specialize it, you use something called a values.yaml file, which can like lay on top of it. The problem with values.yaml is when you implement your Helm chart, you have to write in your Helm chart the values that you support, right? So if like I make a Helm chart and I say, here, use this Helm chart to deploy, and I say, here's the 5 values that you can override, but you think, I need to override this other value that you have not accounted for. Like, how do you do that, right? You have to fork the Helm chart and then like maintain a fork of the Helm chart, and then use sed in your CI system to, you know, if you want a different version for different places, etc. What JSONet lets you do is maintain those differences in a sane way, even if I didn't predict, right? So I say, here's my JSON description, and then you can override anything that you want or add anything that you want to it. And then you can render a Helm chart if you want. So if you want to use JSON to produce Helm YAML, you can totally do that, and then use the Helm tool to actually deploy and maintain like the life cycle of that chart if you want. Did that answer the question?
Yeah, I would ask you, can you go the other direction though? Can you take a Helm chart that's out there and then use JSON to extend it somehow? Because I'm thinking, you know, like you said, Helm is the way we package all this stuff.
I'm gonna say yes, but like a very soft yes. Like I feel like I'm sure if you talk to enough, you know, JSON fans, they'd be like, absolutely, and show you how to do it. I'm just not sure if that would be sane or maintainable. You know what I mean?
I'm just thinking you have all these Helm charts out there that have already been developed, and so writing a JSON that goes into a Helm would require that that Helm chart supports that, right? And so could you take one that already exists and then extend that with your own JSON?
I'm pretty sure people do that, but I don't think that's really the state of the art. I think people are using something called Customize to do that now, which is like a different tool which lets you inject custom YAML. Like, so I think that's probably what I would do, because that's like the way the community, the Helm community is tending. I just find it easier to go with the flow. If you're like, JSON is so much better than Customize for these technical reasons, I might actually be right, but then 6 months later, I'm going to be completely on my own. So I'd rather, you know, like if I were using Helm charts, I'd rather go with Customize. That's my personal opinion.
Thanks.
Oh, rough split feature flag tools. Okay, cool. I'll look into those. Bad acceptance. Are you considering bypassing? You just think it doesn't add enough value that having should be a blocker? I'm considering just getting rid of it. Like, just to be clear, I'm getting a lot of pushback. There's a lot of fear about this. But when I just look at the actual data, I don't think we get any value out of it. And like the effort that we expend and the expense that we expend on it, I think would be better put at just getting really good at just like doing GitOps right into production. And like, I probably sound insane to a lot of you, but I think that is the state of the art. Like, I think that is where like leading DevOps practitioners are sort of are taking us. Like, get really good at feature flagging, test in production. And if you think that you have a problem that has to have an acceptance environment, like, you just haven't thought about it hard enough. That I'm being very hand wavy as the head of the platform, right? But
because if just have, given that you want people to feel comfortable continually releasing to production, even though it doesn't catch a lot of, you know, some number of errors, and it is itself an effort to maintain, doesn't it help provide a psychological support for people being able to push, just knowing it's like, well, if I'm really going to screw the pooch here, at least we'll find out in acceptance and not in production.
Yes, and that's the way we use it. But then, like, the way I would like to challenge my team is to like, wait a minute. Why do you think you're going to screw the pooch? Like, why do you have that fear? And like, you should go back and address that root cause, right? Like, that means, like, do we need to think more carefully about how we're rolling out this change? Is there a smaller, like, can we break it down into a smaller, safer sequence that we, you know? So that's just the way I would like to challenge my team. Like, we're not there yet, but like, that's where we're going. Does that make sense, Peter, or do you think I'm just insane? Like,
yeah, I see what you're saying, that push all that scary stuff further to the left, further upstream. What is upstream from you then, in terms of testing how the pieces come together, or to assuage some of that and provide some of that knowledge that the changes you're making are relatively likely to not bring down the system?
yeah. So we really rely on our CI system for that. right? Like, can I build the whole thing and will these tests pass, right? And then we have something that we call the end-to-end test suite, right? It's like we run some tests. Like we run a whole bunch of unit tests before you can even get into, like, before you can even like get your pull request, like even into the CI system basically. And then CI will build everything and then run another test suite, which is, you know, the unit test, but also a whole bunch of other stuff. And that we have found has been like the best safeguard, that plus feature flagging. And like recently, like just today, we started doing this thing that we call shadow services. So we made like, we have this like fundamental part of our system, which is like the core language parser, and we've re-implemented it. But it's like a brand new implementation. And so we released what we call a shadow version of it, which is a set of pods that have the new functionality in it. And we're keying the data. So we tell Istio, like, send the requests to the actual production one that's actually going to serve users, but then also send it to the shadow one and then compare the results. And so we just have a dashboard that's just showing like, are the responses the same? And like in that way, you know, we can like shake out all the problems, but like in production, right? Like, we got an what the heck happened, right? How come we got an here, but not in CI? And then we can like shake it out there, but it's in production. Like, anyway, look, clearly I'm very opinionated about it and very passionate. I do respect that I'm pretty far on like, you know, one end of the continuum on this. And like, to be clear, like we're on a journey also. We're not, you know, we're not at the end point where we're doing perfect GitOps. So one more question, I guess. Okay, 2 more questions. Any advice on an organization implementing the idea of infrastructure as code? I would suggest to pick up Terraform and just start with a small thing with Terraform. I think Terraform is like likely the most that seems like the tool that is most likely to be the most popular like in the current generation. And it does a whole bunch of things and there's a huge community around it. And so that's a tool from HashiCorp. Just start small and just, you know, do something small and repeatable from there. And my favorite thing about Influx that are going to show a new employee. Do you mean about the product? Oh, geez, I wish I prepared. I tried really hard not to not come and like sell Influx because like people do use it in developer tooling. But we have this thing called Flux, which is a new language that we're developing, which is a data transformation language. And it can seem a little hard to love at first because it's not like anything that you've used before. But once you have started using it to solve problems, it's amazing what you can do with Flux. And yeah, it's so I think that is the coolest thing that we have. That's kind of like our diamond in the rough. I think that's nobody else has anything like that. So, okay, thanks very much, everybody. It was a super privilege for me. I really enjoyed coming and sharing with everybody.
Thank you.
Yeah, thank you so much for presenting. We really appreciated having you, and we will hopefully hear from everyone online over the next month or so.
Okay, I will just to add, I joined the Slack that you had.
Oh, wonderful! That's awesome.
To get into the nitty gritty, just Slack me, and I'll use it also as a resource if I have any questions.
Thanks, everyone.
Rick, I just invited you to the Slack, to the DevOps channel on Slack.
Okay.
Yep. Thanks, everybody. Feel free to, wave goodbye or put a message in the chat thanking Rick on our way out here.
Thanks, Rick. Thank you, everyone.
Thanks, guys.
See you all next month.
See you then.
Yep. Take care, y'all.
Bye, everybody.
Bye.